Alright, this is section 7-8. This is called prediction equations. Alright, so this is example 1. On page 403 it says, the table shows the changes in the number of college-bound students taking the ACT. ACT is a college test where they evaluate students across the country. And there's a part A, part B. So part A says make a scatter plot, which we've done. This is a scatter plot here. I didn't label it perfectly with the words, just for the sake of time. But there's the numbers. It's approximately labeled correctly. And the other thing it says is to draw a line of fit for the data. It's also called a line of best fit. Alright, so this is a scatter plot, which means all the points are just scattered across. You can look at the table in the book. It's approximately what the numbers say. But a line of best fit is similar to drawing a line in which the line basically fits the data. Alright, so we're trying to draw a line that fits a pattern. Alright, so what I'm trying to do here, as you can tell, is just draw a line that goes through the data. Try to have the same amount of points on the left side as the right side, and you want your line to basically fit the pattern of growth or decrease that the points are having. Alright, so part B says, so we're done with that. That's the line of best fit. Your line of best fit might be different than mine, but that is a line of fit. And part B says to use the line of fit to predict the number of students taking the ACT in 2015. Alright, so here's what we do now to make this guess. You can see in the book how they did this. They drew the line even longer and then tried to find where 2015 is and match that to where the number of students would be. So for us, here is 2015. So if I go straight up, and I'm going to learn that my line is just not big enough for my line of fit. It's going to hit that line somewhere up there. Let's pretend it's around this spot, and let's say, what I'm trying to do is find that line where it hits over here, which my line of best fit looks like it'll be around somewhere around 1600. So it says to make a prediction. Well, for my line of fit, my prediction is around 1600 is where that would be in the year 2015. The book says around 1480 because their line of fit hits that line in 2015 around 1480. Alright, so for example 2 on the next page, 404, it says the scatter plot shows the winning Olympic times in the women's 800-meter freestyle event from 1968 through 2004. Write an equation in slope-intercept form for the line of fit that is drawn. That's part A. Part B wants you to predict the winning time in the women's 800-meter freestyle event in the year 2012. Alright, so what I want you to look at is the graph they've given you. Alright, they show you the graph. And so they plotted all the points from a table, and they've drawn that red line, or on your copies, obviously it's a little gray line that goes through there. And what that line represents is basically how the dots are increasing or decreasing. So that's the line they chose to draw. And what you can see on there is that on that line they've created 2 points. So they tell you 2 points. What we're going to do is use those 2 points like we did last section and create a y equals mx plus b equation. Alright, so this is the kind of equation we're going to create. First thing is to figure out the slope, and the way to figure out the slope, remember, is delta y over delta x. The change in the y's. We'll just look at the points. You can read them right there. It goes from 525 to 500. That is a drop of 25 if you just look at the y's. And then the years, the 1980 to 1992, that is an increase of 12. And so as we continue here, that is m. Right now in the book you can notice where they changed negative 25 over 12 to a decimal. But that for us, that's the exact answer. It's a fraction and it's in simplest form. Then if you remember last section, the next thing we've got to find is b. So the method that I taught you was to find b, let's choose a point to plug in for x and y, and then we can figure out what b is. So choose either 1980, 525 or 1992, 500. I'm just going to use the 1992 x and 500 for y. So I'm going to plug that in. Doesn't matter again which one you choose. 1992, 500. Alright, so now I'm going to have to solve this. So with a calculator here, if I took negative 25 over 12 and multiplied it by 1992, I end up with negative 4,150. Now again, I'm just going to keep dropping all the rest of these things down. Alright, so the next thing here, I'm going to rewrite this equation. Alright, so I rewrote the equation down here now. So I've got to solve for b, and the way to get b all by itself in this case is to add 4150 on both sides, and that should give me 4650, which equals b. Now if you look in the book, their answer is slightly different. They have 4683, and that is because they used the decimal negative 2.1, which is a rounded answer. I used approximately the exact answer. So that, my equation, I think is actually more accurate. And so the last thing for part A is we're going to write this equation in slope-intercept form. There you go. Alright, as I said before, the equation in the book actually looks almost exactly the way mine does, but I think mine's more accurate. Let's go to part B now, which is predicting. And here's part B for example 2. It says predict the winning time in the women's 800 meter freestyle event in the year 2012. Well, just looking back at this stuff, remember the years, if you look at the graph, the years are the x-axis. So if it's saying the year 2012, that's going to get plugged in right there for x, since that's the x values on. Alright, so we've got 2012 being plugged in there. And again, we're trying to find y because we're making a prediction. Right? This is where we use our equation now to make a prediction. Example 1, we were using a graph to make a prediction. Here we're using an equation to make it a prediction. So as I plug it in, I'm going to have a little bit different of an answer. And using a calculator here, I took the fraction times 2012, and then I added 4,650, and my approximate answer is that y is around 458.3 repeating, which if you look back at the graph, that's talking about seconds. So I'm predicting that in 2012 the winning time will be around 458.3 repeating seconds. And you can look in the book, it has an answer really close to that, but their answer is based on a different equation. So keep that in mind. Alright guys, best of luck. I know this might be a tricky section, but it is the end of chapter 7.